Alright, welcome back. In this video, we're going to be talking about extreme values of sine and cosine, which is going to be basically, extending our discussion of trig functions to inputs of 0 radians and multiples of pi over 2 radians. So down at the bottom, you can see really what the true definition we're going to take in this class of sine and cosine are. AP pre-cal level definition, not just SOHCAHTOA. So, given an angle theta in standard position, which I've kind of drawn you there, AOB is in standard position, there's a point P where the terminal ray of that angle intersects the unit circle. All right, so I'm going to draw a unit circle. Okay, I'd say that has radius 1. And then I'm going to label the point of intersection between the, okay, there it is, between the terminal ray and the unit circle. I'm just going to call that P. And now I'm going to draw in a reference triangle like we always do. And there it is. But that's a little small, so I'm going to draw a larger replica off to the side. All right, so there we go. That's a replica I can work with. So I'm thinking maybe we give the coordinates of point P some kind of name, maybe X and Y. So I'll just label that point P, X, and Y. Okay, and then I'm going to label the triangle. Okay, now I know that this is a unit circle, so the radius of the blue circle is 1, meaning the hypotenuse of the red triangle is also 1. Okay. So I've got 1, and as a result, I can also say X and Y are going to be the side lengths, right? Because that's how I got to point P, is I went to the right X units on the X-axis and up by Y units on the Y-axis. And from there, okay, so on a SOHCAHTOA level, think about it, it's the vertical displacement of P from the x-axis represents sine theta. That's the y-coordinate of point P. So I'm going to actually write in y equals sine theta on the unit circle. And x is going to equal cosine theta, as long as we're on a unit circle. Okay, and if we were not on a unit circle, it'd be the ratio of the, say for sine theta, it'd be the ratio of that vertical displacement, which could be negative, to the hypotenuse of the triangle, or the radius of the circle that we're intersecting with. And, like it says down below in your notes, this characterization of sine and cosine is going to make a lot of sense considering what we saw last time with some of the values going negative and everything outside the first quadrant. So let's go in and let's look at these 4 places and think about sine and cosine at these. This is something we haven't done yet. So, at theta equals 0, let's zoom way in on that. I'm going to draw a unit circle. All right, normally if we're given a radian input and we're asked to do trig, we're going to follow the same 3-step process every time. Find the spot on the unit circle, then we'll draw a reference triangle, and then we'll do SOHCAHTOA. Okay, but that's not going to really work for theta equals 0, okay? Because you know where theta equals 0 is. It's at the very beginning of the unit circle. So I'm going to draw the initial ray, draw the terminal ray. Oh wait, it's the exact same ray. Okay, well that's theta equals 0. So the point P right here, that's point P. Whoa, what's going on there? That's more like it. And so what I'm going to do, I'm going to label the coordinates of the intersection point. Now this is a unit circle, right? So it's all of the points on the black circle are 1 unit away from the origin. And this is at the far right edge. So this is going to be the point where X is 1 and Y is 0. So I'm going to say, keeping in mind what we just said, that the x-coordinate, the horizontal displacement from the y-axis represents cosine. Let's say cosine of 0 equals 1, right? It's the x-coordinate. And then sine of 0 is going to be the y-coordinate of that point, the vertical displacement from the x-axis. I'm no units away from the x-axis because I'm on top of the x-axis. So sine of 0, that's going to equal 0. All right, theta equals pi over 2. We're going to do the exact same thing. We're going to draw the initial ray here. Okay, and the terminal ray will be up here because pi over 2 corresponds to a 90-degree angle. Oh, and I forgot to say, before, if we drew the intersection point and then we tried to draw a reference triangle like we're used to, well, the reference triangle would go back to the x-axis. On the other one, there's nowhere to go. I was already on the x-axis. Okay, so there was no height to the triangle. On this one, there'd be no width. And in the past, last time I taught pre-cal, I drew triangles with sides 1, 1, and 0, and I drew them really tall or really wide, and made one really small and labeled it 0. That did not sit well with students in my class, so we're not going to be doing that this year. We're going to go with the coordinates. So, again, I'm on the unit circle. I'm 1 unit away from the origin at all times. And so I'm on the y-axis, and that's the set of all points where x is 0. And I'm 1 unit above the x-axis, so I'll be at the point 0, 1. And just like before, I'll say, all right, cosine of pi over 2 is going to be the x-coordinate, so that's 0. And sine of pi over 2 is the y-coordinate at that point. It's the vertical displacement from the x-axis. That's going to be positive 1. All right, at theta equals pi. Okay, we know pi is kind of over at the far left edge of the unit circle, so I'll go draw the initial ray, draw the terminal ray, which will be over here. I think for that one I like to put a little dot there to indicate I've rotated all the way around. It's a rotation, not just one continuous line. And, okay, you know, we could also say that's pi radians worth of rotation. I think I like that. And so get that out of there. And I'm going to label the intersection point. Find the coordinates of it. It's a unit circle. It's 1 unit away from the origin. It's to the left. So this is where x is negative. So I'm going to say x is negative 1 and y is 0. And just like before, I'm going to say, all right, cosine of pi. That's the x coordinate, or the horizontal displacement from the origin. I mean, pardon me, from the y-axis. Yeah, I mean, I guess what I said wasn't totally untrue, but it wasn't as easy to see. Horizontal displacement for the y-axis. Displacement is how much you changed. So if I was at the y-axis, which is x equals 0, and then I went to x equals negative 1, that's going to be a displacement of negative 1 units. Okay, that's what they mean by displacement. It could possibly be negative, whereas a distance is going to be something that's positive. Okay, but the difference in language there hopefully is not something you've got to contend with in this class. I don't think you do. And then the y-coordinate represents sine of pi. The vertical displacement from the x-axis, I haven't been displaced at all. Okay, I'm still on the x-axis, so it's going to be sine of pi equals 0. All right, now the last one I've got, or maybe almost the last one I've got for you on these extreme values here, is theta equals 3 pi over 2. Okay, now theta equals 3 pi over 2, I kind of need to just know where that is. Okay, pi over 2 is one 90-degree rotation counterclockwise, so 3 pi over 2 would be 3 such rotations counterclockwise 90 degrees. Also, pi is to the far left, so 1.5 pi, either way, it's got to be down here at the bottom. All right, but that's going to be one of our important unit circle stops. I'm going to label that amount of rotation as 3 pi over 2. And then I can't really draw a reference triangle, so I'm going to label the coordinates of the point of intersection. Okay, so the coordinates of the point are x equals 0 and y equals negative 1. Okay, so I'll say that cosine of 3 pi over 2 is 0. I haven't been displaced from the y-axis at all. The horizontal distance from the y-axis, or pardon me, horizontal displacement is 0 because I'm on the y-axis. Okay, but then sine of 3 pi over 2, from the x-axis, I've gone down 1 unit, so that's a vertical displacement of negative 1. All right, and before I moved on, I kind of wanted to talk about 2 pi. Okay, theta equals 2 pi, because we know that that's in the same spot as theta equals 0. If I make a whole rotation, I'm back to where I started. So I think, let's say this one could also describe theta equals 2 pi. And if, I wanted to say, all right, well, that means that cosine of 2 pi is also going to equal 1. And sine of 2 pi is also going to equal 0. Okay, because they are what we're about to call in the next video coterminal angles. So let's go in and do a few more examples. Now that we've got that, we need to probably talk about some of the reciprocal functions, because if sine cosine can go 0, then that means that the reciprocal functions could possibly go undefined at these places if we were dividing by 0. So I think if I want to find out which of these values don't exist, I'm going to need to try to compute them. So I'm going to bring in some axes. Okay, and so we're kind of going to apply the same strategy as usual, except the second step, instead of draw a reference triangle, will be label the coordinates of the point. So first, find the spot that corresponds to theta equals 0. Okay, I'm not going to draw a triangle. I don't think that's necessary. I think we're going to say, all right, or draw a circle. I don't know if I said draw a triangle, but we're not going to draw a circle because I don't think it's necessary. This is the point 1, 0, okay, on the unit circle. And so secant is equal to 1 over cosine. So the cosine is the x-coordinate, so it's 1 over 1. And that's just 1. Okay, nothing wrong there. Okay, tangent of pi over 2. I'm going to label the spot where pi over 2 is. That's up at the top of the circle. And that's 1 unit away from the origin on the y-axis. So x is 0 and y is 1. Okay. tangent is going to be, okay, I guess we haven't really talked about that, but I've told you before that tangent is sine over cosine, or opposite over adjacent. But opposite and adjacent only really works when we've got a triangle to work on. Okay, but what I told you earlier, that cosine is represented by the x-coordinate on the unit circle, and sine is represented by the y-coordinate on the unit circle. We're going to use tangent theta equals y-coordinate on the unit circle divided by x-coordinate on the unit circle. Copy that in. You know, while I was at it, I thought it might be useful to copy in the thing about cotangent is going to be the x-coordinate divided by the y-coordinate. All right, so I'm not at room here, but it'll be all right. So tangent of pi over 2 is going to be, go off to the side so I'm not saying anything that's patently untrue and publishing it to YouTube. But it's the y-coordinate over the x-coordinate. 1 divided by 0, that's not going to exist. So I'm going to say tangent of pi over 2 does not exist. And in our class, D and E is a perfectly fine abbreviation for does not exist. You could say undefined, something like that. I mean, as long as you're indicating that this value is not a real number, it's not existing. Okay, cosecant of pi. Find pi on that circle. It's over there at the far left edge. Label the coordinates of the point. X is -1 and y is 0. Cosecant of pi is 1 over sine of pi. So I might write out, okay, sine of pi equals the y-coordinate here, and that'll equal 0. As a result, cosecant of pi is going to be 1 over 0, which is also going to not exist. Okay. Cotangent of 3 pi over 2, I'm going to go over here. This one is going to exist. So the coordinates of this point are x is 0 and y is -1. Okay, and like I said up there, highlighted in yellow, cotangent is going to be the x-coordinate divided by the y-coordinate. So I'm going to say, all right, that's equal to the x-coordinate on the unit circle divided by the y-coordinate. Okay, 0 divided by -1. We can divide 0 by anything. It's going to be 0. I guess we can't divide by 0 by 0, but as long as we're not divided by 0, we're going to be good to go. Okay, that's really the only thing we're not allowed to do here. So cotangent of 2 pi. Locate 2 pi on the circle. That's the same as 0. It's the far right edge. Coordinates are 1 and 0. Cotangent is x-coordinate divided by y-coordinate. 1 over 0. That fails to exist, right? Can't be divided by 0. Okay, cosecant pi over 2. Find pi over 2. Label the coordinates. And then think about, all right, well, sine of pi over 2 is going to equal 1. Okay, so cosecant of pi over 2 is going to equal 1 over 1. And we already saw that happen once. That's going to be 1. Okay. Tangent of 0. Go over to 0 radians on the unit circle. Label the coordinates of the point. X is 1, y is 0. And tangent is going to be y over x, so 0 divided by 1. And that's going to be 0. Okay. And then secant of 3 pi over 2. All right, 3 pi over 2 down here. Coordinates x is 0, y is -1. I'm going to need cosine if I want to find secant. So cosine of 3 pi over 2 is the x-coordinate there, which is 0. So then I'm going to take 1 over 0, and I'm going to see that fails to exist because of division by 0. And so, you know, I guess back to the original question, which of these values do not exist? That would be tangent of pi over 2, cosecant of pi, cotangent of 2 pi, and secant of 3 pi over 2. All right, now I got one more extra example for you. I'm thinking, I think this will be good for you. Whoops, there you go. The point 0, -7 falls on a circle with radius r at a radian measurement theta in standard position. What are r and theta? Okay, now I think this one's a little easy. I adapted this from a question that was not at one of the extreme values, but I thought it was a good question and was getting at the idea of polar coordinates, which we're going to be doing here before too long anyway. So I'm going to copy in a circle. All right, and I'm feeling like I probably should have said something about the circle being centered at the origin. But, you know, I think you'd assume it is, and we don't really deal in this class, at least at this point. I don't think at any point we're not going to be dealing with circles that aren't centered at the origin. Because I was like, oh, what's the point? Okay, so the point 0, -7. All right, well, that's on the y-axis down 7 units from the origin. Whoops, it's not going to like that. Well, maybe it did, but there we go. Okay, coordinates of the point are 0 and -7. And so I think that means that the radius is going to be, 7, that distance here. So r is going to equal 7. And theta in standard position, all right, well, the initial ray was here. terminal ray is going to be down here. Kind of wanted that to be behind the red, but it's all right. I think I can make that happen. There we go. Yeah. All right. So the terminal ray is right there, meaning, you know, if you wanted a positive angle, you'd go around that way, and that will be 3 pi over 2. But I want to point out that that's not the only way. If you, I mean, I haven't really talked about negative angles besides that they rotate in a clockwise way. You could also say that that was theta equals negative pi over 2, and it would be just as right. Okay, so I think, yeah, that's going to be all of the examples I've got for this video. So thanks for watching.